In this topic, we zoom in on the EU rules that make digital identities and signatures legally reliable across countries. You'll see what eIDAS is, the main trust services it defines, and why they're essential for secure cross-border digital transactions. You've already seen the core ideas of digital identity and trust. Now we look at the rules of the game, how the EU formalizes trust with eIDAS, levels of assurance, and trust services. After this, we'll apply those rules to concrete architectures and a banking use case. Think of eIDAS as the EU's master rulebook for digital trust. It defines how electronic IDs, signatures, seals, and timestamps must work so they're legally reliable everywhere in the Union. Because it's a regulation, not a directive, member states can't cherry-pick parts. It applies directly. The outcome is secure, predictable online transactions that can be treated like paper-based, face-to-face processes, even when they cross borders. eIDAS exists to make digital life in Europe practical. It lets a citizen open a bank account abroad or a business sign a contract online without traveling or sending paper. Its core job is to bring together trust, cross-border interoperability, and clear legal recognition of digital actions. The regulation is really about trust and interoperability, not redesigning your whole identity stack. It sets common rules so member states recognize each other's eID schemes, and so trust services like signatures, seals, timestamps, and certificates work reliably across borders. It doesn't dictate your exact technology, user journeys, or all sector-specific rules. In practice, you layer eIDAS with GDPR for data protection and with financial or AML KYC regulations that govern your specific use case. You can think of eIDAS as a trust bridge. If an identity or signature is trusted in your home country, it should be trusted across the Union. That lets a citizen reuse their national eID to access foreign public services, and a business accept a qualified e-signature from any member state with the same legal weight. In our banking scenario, this makes remote onboarding possible. A customer in country A can open an account with a bank in country B. Under eIDAS, electronic identification is how a verified identity travels into the digital world. It might be a smart card, a mobile app, or a remote solution, but the goal is the same: reliably link a person to key attributes like name and date of birth. Only trusted, notified eID schemes gain cross-border recognition. Levels of assurance are essentially trust levels for identities. Low means minimal checks and lighter authentication. Suitable where the impact of fraud is small, like a basic online account. Substantial adds stronger identity proofing and more secure login, fitting typical government or banking services. High is reserved for situations where errors are unacceptable, such as large financial transfers or qualified electronic signatures. Your role is to align the low A with the risk and liability of each service. As users move from simply logging in to actually opening a bank account, the required assurance level rises. Low or substantial assurance might be enough for a basic login with simple authentication. During onboarding, we need substantial or high assurance, with rigorous identity proofing that also meets banking rules. By the time we reach contract signature, we're firmly in high assurance territory, and strong multi-factor authentication becomes the norm. eIDAS also defines a ladder of assurance for signatures. Simple electronic signatures include actions like typing your name or ticking I agree. They're easy to use, but easy to dispute, so they fit only low-risk use cases. Advanced electronic signatures add stronger identity binding and tamper detection, making them suitable for most business contracts. Qualified electronic signatures go further. They require a certified device and certificate, giving them the highest evidential weight in court. Under eIDAS, a qualified electronic signature has the same legal effect as a handwritten signature in every EU country. If a law asks for ink on paper, a QES must be accepted instead. For organizations, qualified electronic seals play a similar role. They prove who issued a document and that it hasn't been altered, which is vital in high-value banking contracts. Trust services act like the digital equivalents of notaries, registered mail, and ID checks, all implemented in software. Under eIDAS, they include issuing certificates, creating and validating signatures and seals, timestamping, secure e-delivery, and website certificates. Together, they guarantee three outcomes: integrity, so data isn't altered; authenticity, so you know who is behind it, and non-repudiation, so actions can't be denied later. Our banking scenario relies heavily on these building blocks, especially remote signatures. Trust service providers, or TSPs, are the broad category. Any company issuing certificates, timestamps, or remote signing services under eIDAS rules. Within that, qualified trust service providers are the elite subset. They've passed a formal audit, are supervised by a national authority, and can issue qualified certificates and signatures. When your use case carries legal or regulatory risk like banking or public sector, you design integrations around QTSPs, not just any TSP. On top of trust services, eIDAS adds a governance layer. National supervisors audit providers, grant qualified status, and remove it if rules are broken. Their decisions are published in the EU trusted lists, which become the machine-readable source of truth. As an architect, you rarely hard-code trust in a provider. Instead, your systems query these trusted lists, confirm the provider and service type, and only then accept certificates, signatures, or seals as qualified. You've now seen how the eIDAS framework, assurance levels, and QTSP ecosystem combine to deliver cross-border digital trust. Keep that mental map. Risk level drives assurance, assurance drives signature type, and QTSPs operationalize it. Next, we'll turn this into concrete components in an eIDAS-aligned architecture.